Okay, let's unpack this. Welcome to the deep dive. We're here to slice through stacks of info, get you well informed, fast. Today, we're taking a really deep dive into mastering AI workloads. We're going to focus on the essential building blocks, the strategic stuff you need for successful AI implementation, especially within the HPE ecosystem. Now, our insights for this deep dive, they come from what we call exam essentials. Think of these as like super distilled nuggets of knowledge designed to bring real clarity, practical understanding to some pretty complex AI concepts and solutions. So our mission for you today is simple. Quickly extract those crucial bits of knowledge, help you get a solid grasp of the key AI infrastructure, the software components, and importantly, how it all fits together, particularly in a private cloud setup.
Yeah, and what's really insightful about this material, I think, is how these pieces that might seem separate, they actually connect. They really form a bigger picture of how you deploy AI solutions that are genuinely scalable, efficient, and well managed. It's not just about the individual parts; it's the synergy.
That makes perfect sense. Okay, so let's start right at the beginning then. Before we even get into the weeds with specific tech, if someone's thinking about an AI solution, maybe for their customers, maybe for their own teams, what's the absolute first step? Like the foundational thing they really need to nail down about where they stand right now?
This raises a really crucial point. It's something a lot of organizations, well, they sometimes overlook it in the excitement. You wouldn't build a house without knowing who's living there or what they need, right?
Right.
It's surprisingly similar with AI. The fundamental step, it's a thorough AI maturity assessment. You've got to focus on the customers or your own current AI use cases, and critically, their data readiness.
Data readiness.
Yeah, and that's not just do we have data, it's, is it good quality, is it accessible, is it labeled, structured? And what specific problems are you trying to solve with AI? We see it sometimes people jump straight to the powerful tech, only to find out their data isn't quite there yet, or the use case is a bit fuzzy. Understanding that existing foundation is just, well, it's absolutely crucial. It helps tailor the solution to fit the actual needs and readiness level. Avoid some expensive mistakes down the line.
Okay, so for you, our listener, thinking about your own AI journey, that honest look, assessing your data readiness, defining those current use cases, that's paramount. It really does set the stage for everything else. Because, okay, once you've got that clarity, the next big question is, well, how do you actually power this vision? That takes us to the hardware, the raw horsepower, the infrastructure that's really the backbone of any serious AI setup. When we talk about accelerating AI, what's the first component that just leaps out?
Oh, for raw acceleration, especially deep learning, it has to be NVIDIA GPUs, no question.
GPUs, yeah.
Their main benefit, particularly in something like an HPE Private Cloud AI environment, isn't just about raw speed, though. It's about enhanced real-time inference performance.
Real-time inference. What does that mean in practice?
It means making AI actionable, like instantly. Think about fraud detection in finance, maybe, or recommending the next video on a streaming site.
Right. Got to be fast.
Exactly. Waiting even a few seconds makes the AI pretty useless in those cases. Real-time inference means the model gets new data, gives you an answer, boom, right away.
Yeah.
Enables stuff that just wasn't possible before. And housing that kind of power, well, that needs special hardware. The HPE Apollo 6500 servers, they aren't just boxes you stuff GPUs into. They're engineered, like from the ground up.
Right.
They handle the specific power demands, the cooling, the high-density interconnects that these massive AI workloads need. That stops things like thermal throttling, makes sure you get sustained peak performance. That's often a hidden bottleneck with generic hardware,
Okay, this is where it gets really interesting for me. You've got these super powerful GPUs, maybe lots of them, running distributed AI training across different machines. They need to talk to each other like incredibly fast, don't they?
Oh, absolutely.
So what network feature is just absolutely critical for that high-speed, unbottlenecked chat between GPUs?
You've hit on a really critical point there. Without the right network, those extensive GPUs are basically just waiting around.
Right, sitting idle.
Exactly. For distributed AI training, the non-negotiable network feature is low latency, high bandwidth interconnects. Think things like InfiniBand or Slingshot.
InfiniBand, Slingshot. Okay.
Yeah, these aren't just faster Ethernet cables. They're specialized technologies.
Yeah.
Purpose-built for extremely efficient data transfer and synchronization between all those compute nodes. Think of it like this. GPUs are Formula One cars. InfiniBand or Slingshot. That's the perfectly smooth multi-lane Autobahn, letting them hit top speed, no traffic jams. Without that, even the fastest car is stuck in gridlock. Scaling your AI training across a cluster just It just doesn't work efficiently.
All right, all right. So we've got this seriously powerful infrastructure built for speed, built for communication. But honestly, managing all this, monitoring these complex AI environments, especially when they're distributed, that sounds like a potential nightmare. You can't just wing it, can you? What tools are out there to give you that kind of consolidated view?
Exactly right. It can be a huge headache. And that's where the software and the management layers become completely indispensable. For that centralized oversight, HPE GreenLake Central plays a really vital role. It's the primary platform for centralized infrastructure monitoring and management.
Okay, Green Lake Central.
Yeah, it gives you that unified view. Your whole IT infrastructure, including all your AI workloads, visible from one place. And it's not just about seeing blinking lights, right? It actually streamlines operations, gives you deep insights into resource use, performance metrics, critical alerts, all from a single pane of glass. It saves, countless hours you'd otherwise spend jumping between different management tools.
Makes sense. And beyond just watching the infrastructure itself, what about the AI models, the things actually doing the work, from like initial development to deployment, then tweaking them, refining them? How does a platform like, say, HPE Ezmeral help manage that whole life cycle? Because I imagine that can get messy really fast too.
Oh, it can get incredibly messy. You've nailed it.
Yeah.
That's what Esmo really brings to the table, the ability to sort of tame the chaos of
Ew.
MLOP,
ML
machine learning
Wait,
operation.
MLOps, right?
It facilitates that whole AI model lifecycle management. It does it through comprehensive model versioning, automating deployment, automating monitoring. Imagine a data science team. Models are constantly changing, keeping track which version did what, deploying a new one without breaking something else. Nightmare potential.
Yeah, I can see that.
Ezreal provides the guardrails, the automation, turns that potential chaos into a streamlined, repeatable pipeline. It speeds up innovation, reduces risk significantly. It's essentially about bringing those robust DevOps principles that software developers rely on into the AI and machine learning world.
That sounds like a massive help for a lot of teams, okay? And for scaling. Scaling AI workloads up, scaling them down as demand shifts, because let's face it, that's constant in AI. It's dynamic. What kind of platform gives you that critical flexibility, that automation?
Yeah, for the dynamic flex and automation, you're looking at container orchestration platforms. Things like Kubernetes are absolutely essential here.
Kubernetes. Yeah.
Their main benefit, especially in an HPE Private Cloud AI context, is the automated deployment and scaling of AI workloads across your infrastructure. This is just crucial because it lets AI applications run reliably, scale dynamically when demand changes, all without someone constantly intervening manually. If you suddenly get a huge spike in requests for your model, Kubernetes can automatically spin up more instances to handle it. Then, just as importantly, scale them back down when things quiet down. Keeps performance up and costs under control.
Okay, so let's recap a bit. You've got the vision, you understand the pieces, the GPUs, the network, the management software, the scaling platforms. But how do you actually make sure everything is sized right? That it's all validated before you deploy? I remember trying to build a custom PC back in the day and finding out 2 parts weren't compatible after buying them. This must be that problem, but like on a massive, much more expensive scale, right?
Yeah, exactly. A much more expensive headache at enterprise scale.
So are there specific tools that take the guesswork out of configuring these really complex AI solutions?
Absolutely. It's far too risky and expensive to guess. That's precisely why these sizing and validation tools are so important. The HPE Intelligent Configurator tool. Its whole purpose is to size and validate hardware and software components. It makes sure your planned configuration meets all the performance needs, the compatibility requirements, the scalability targets before you commit.
Okay, that sounds useful.
And complementing that, there's OneConfig Advanced, or OCA. Its role is critical too. It helps in generating validated and scalable system configurations specifically for HPE AI solutions. It really simplifies and speeds up the whole design process, ensures that configurations are robust, meet all the reliability checks, saves a ton of time, and frankly prevents some potentially disastrous errors down the road.
That peace of mind alone sounds pretty invaluable. Okay, finally then, let's talk business model. Money. AI projects can be significant investments, right? And often growth is kind of unpredictable. How does the HPE GreenLake approach, that consumption-based model, how does that benefit AI projects? Especially thinking about cost and flexibility, because that hits the bottom line, doesn't it?
Oh, it absolutely hits the bottom line. And maybe even more critically, it impacts the ability to innovate. It really raises that important question for so many organizations. How can you actually do cool stuff with AI without this massive upfront capital spend? Especially when you might not know precisely how much capacity you'll need next year or even next quarter.
Good point.
So the key benefit of HPE GreenLake's consumption-based pricing for AI projects, it enables scaling resources based purely on demand and usage. This fundamentally changes the game. It avoids those huge upfront hardware purchases. It provides significant cost efficiency because, well, you literally only pay for what you use.
Pay as you go for AI infrastructure.
Essentially, yes.
Yeah.
And you can scale up easily if your project takes off or scale down if priorities shift. That gives you much greater agility, much more financial flexibility. It makes AI adoption feel more accessible, more manageable, even if your workloads are unpredictable.
So here's a final thought for you to maybe mull over. Given the sheer pace of AI innovation right now, and you couple that with the rise of these consumption-based models, this need for really adaptable, scalable solutions, how might these integrated AI platforms fundamentally change the way businesses approach their entire IT investment, their whole innovation strategy in the coming years? Like, what does owning IT even mean anymore in this kind of landscape? Something to think about. Thank you for joining us on this deep dive.